Question 10a. Find a proportion of the digits recalled correctly after 3 hours according to this model. Give your answer correct to 2 decimal points. So what this question wants us to solve for is basically when time is equal to 3. So t stands for hours. They want it after 3 hours. So I'm subbing in 3 for t into my function. So everywhere I have a t, I'm basically subbing in a 3. So I'm basically finding p of 3. So that's 0.82 minus 0.12 ln of 3 for t, and then add on my 1. So that's giving me p of 3, which is, when I work this out in my calculator, 0.653645. And it wants it to 2 decimal points, so that's 0.65. So the proportion of digits recalled is 0.65 of the digits. Or as a percentage, that would be 65%, but the question doesn't want it as a percentage, it wants it to 2 decimals. Moving down now to part B, after how many hours would exactly 55% of digits be recalled correctly according to this model? Give your answer again to 2 decimals. So I'm taking my function from the top of the page, 0.82 minus 0.12 times the natural log of t plus 1. Now this gives me the proportion of digits recalled. Now the proportion of digits being recalled here is 55%. My next step, I should say, is to write that as a decimal. So t plus 1 and 55% as a decimal, divide 55 by 100 because there's 100%, is 0.55. Next step I'm going to do is move over this as 0.82 or subtract 0.82 from both sides. So just rewriting that is going to give me 0.55 minus 0.82. And tidying that line up now is going to give me minus 0.27. I'm then going to divide by the minus 0.12 because it's stuck to that log. So that's giving me ln of t plus 1 is equal to minus 0.27 over minus 0.12. The 2 minuses there will become a plus, and 0.27 divided by 0.12 is giving me 9 over 4, or 2.25 basically. The next step now is coming from my log table. So I need my logs here now on page 21. And I'm using the top right hand corner here of the log tables, which has a to the power of x is equal to y, is the same as or implies that the log of y to base a is equal to x. So I'm using this here to help us solve for t. Now if I just come back down here, I have the natural log of t plus 1. Now that's the same as, so ln of x is the exact same as me writing that as log of x to the base e. So that's my natural log. So I'm just going to rewrite this here as log to the to my x, which is t plus 1, is equal to 9 over 4. So I'm just rewriting my log there. Instead of calling it ln, I'm writing it in terms of the log. Okay, so we're basically working backwards here. So my a is going to be my base, which is e. I want to put that to my power, which is my x, which in this case is my 9 over 4. And that's equal to my y, which is t plus 1. And when I evaluate the left-hand side on my calculator, e to the power of 9 over 4, that gives me 9.4877 is equal to t plus 1. Subtract 1 from both sides or move over that 1 is giving me 8.4877. So I just subtracted from 1 there. Subtracted the 1. And the question wants it to 2 decimal points, so that would give me 8.49 as my value for t. So 8.49 hours, basically, is what this is getting us to do. Part C, part 1, find the value of p dash of 1. So this is the derivative of the function. So just taking down my function from the previous part, I get to differentiate this now. So p dash of t, so I need to differentiate it before I can sub in 1. Differentiating the constant will go, so that's leaving me with minus 0.12 times the derivative of ln 1 or t plus 1. Using my log tables, that's giving me 1 over t plus 1. So that's the derivative of p of t. Now I'm going to solve that for p dash of 1. So everywhere I have a t, I'm subbing in 1. So that's giving me 1 plus 1, isn't it? And when I work that out, I'm going to get p dash of 1 to equal minus 0.12 over 2, which is the same as minus 3 over 50. Part 2, p dash of t is always negative from 0 to 12. What does this tell us about the proportion of digits recalled correctly after t hours according to this model? Well, one thing we could say there is that the proportion of digits recalled between the times of 0 to 12 is always decreasing because it's negative. So that's C part 2. Moving down then to part D, use calculus to show that the graph of y is equal to p of t has no point of inflection. So just recall here, how do we actually show or find the point of inflection? So point of inflection is found when your second derivative is equal to 0. So when you solve your second derivative and let it equal to 0. Now our function p of t from the previous page is 0.82 minus 0.12 ln t plus 1. From C part 1 we found the first derivative to be minus 0.12 over t plus 1. So that was our first derivative. Now I need to get the second derivative. So in order to find the second derivative, I have a fraction here. So I'm going to use, from my log tables, my quotient rule. So I'm using the quotient rule here now. So my u is equal to the numerator, minus 0.12. Differentiating my numerator, it's just going to become 0. I get my v, which is the denominator, t plus 1. Differentiating the denominator, I'm just differentiating t, so I get 1. So subbing them in now to my quotient rule, I'm getting v, which is t plus 1, times du, which is 0, minus u, which is minus 0.12, times dv, which is 1, and that's all over v squared, which is t plus 1 to be squared. So again, that's the quotient rule from my log tables. Letting that equal to 0 because it's the point of inflection. So working that fraction out, I get 0 minus minus, which becomes a plus 1 or 0.12 all over t plus 1 squared equals to 0. I want to solve this fraction, so I'm going to put the 0 over 1 and cross multiply. So 1 times 0 plus 0.12, well that's just going to give me 0.12. 0 times t plus 1 all to be squared. Multiplying that by 0 is actually just going to leave me with 0. So you can see here now that I have 0.12 is equal to 0, but I'm going to say since 0.12 is not equal to 0, clearly, then therefore no point of inflection, because I would have been hoping to get 0 is equal to 0 in order to prove it had a point of inflection. Looking now at part part 1, if we learn a skill and then don't practice it, how well can we do? It usually decreases over time. For example, if you learn to play the guitar and then don't play the guitar for a number of months, you'll probably not be as good as playing the guitar the first time you try it again. This effect can be modeled by the following equation. So part part 1 says write C in terms of log a to the base 10, log b to the base 10, and log t plus 1 to the base 10. Okay, so this is basically just manipulation of the function or the equation that we're given. We'll need your log tables on page 21 to answer this question here. So let's begin and see what we have. So I have b times t plus 1 to the power of c is equal to a. So that's what they're giving us. Let's just isolate the t plus 1 to the power of c. That's the same as dividing across by b. So t plus 1 to the power of c is equal to a over b. Okay, so nothing major there. Log tables now, page 21. Let's see, can we start changing this around a little bit? So from the logs, we know that a to the power of x is equal to y. implies that log of y to the base a is equal to x. So that's page 21, bottom right hand corner. So let's change this around a wee bit. That then will give us log of my y. My y in this case is a over b. To the base of a, well, the base here, a little bit trickier. The base here is going to be t plus 1. And that's equal to my x, which is going to be my c, which is my power, in other words. So now I've got c is equal to log of a over b to the base t plus 1. And I'm doing that because the hint is in the question, because it wants us to write each of these in log form. Next thing I want to do now is look at the question. It wanted to base 10. So I'm going to now use the bottom right hand formula on page 21 of the logs. And on the bottom right hand corner, it's given as, let's just write it down, log of x to the base b is equal to log of x to the base a over log b to the base a. So in this question here, I'm trying to get rid of my base, which is t plus 1. So in other words, that's my b in this question. And I'm trying to change it to a base of 10. So manipulating this now, I'm going to leave myself with, well, let's just write it all out again. So I have c is equal to log of a over b to the base t plus 1. And I'm now going to change that to log of a to the x. Well, that's going to give me log of a over b to the base 10 all over log of my b, which is going to be my t plus 1 to the base 10. Now I can actually change that top line. Look at the way I've log of a over b to the base 10. Go to page 21, second rule down on the middle column. How do I deal with a fraction? I subtract them from each other. So that's going to give me the same as log of a to the base 10 minus log b to the base 10 all over log t plus 1 to the base 10. And I think I'm done, because the question wants us to write c in terms of log a, log b, log t plus 1. And that's what I've done. Final part, E part 2. A student got 80% on a guitar exam. After 2 years of not playing the guitar, the student got 47% on the same exam. Use this to find the value of c in the model above, correct 3 decimal points. So using the equation from above, a is equal to b times t plus 1 to the power of c. So that's coming from the top of the question here. A is going to be the grade that the student got in the original exam, the measure of how well you've done at time 0. So A is going to equal to my 80%, the original exam. That's 0.80 as a decimal. B then is going to be the measure of how well the student has done sometime into the future. So that's my 2 years later, in other words. So that's my 47%, which is going to be 0.47. Now, T in the question here is 2 years. But if you go back up to the top of the page here, it tells us that T is measured in months. So I need to convert 2 years into months. So 12 times 2 is 24 months. So T is equal to 24 here. Now I basically just have to sub that in to my equation. So I'm just going to box that off. That's a little bit of rough work there. So I have A, which is 0.80, is equal to B, 0.47, times T, which is 24 plus 1 to the power of C. C is what I'm trying to solve for here. So 0.80 is equal to 0.4725 to the power of C. Let's just isolate the 25 to the power of C on its own. So 25 to the power of C is equal to 0.80 over 0.47. I'm dividing across by that 0.47 basically. So how's that looking now? Let's again use our logs, page 21, bottom right hand corner here. which is given as a to the x is equal to y, is the same as the log of y to the base a is equal to x. So I'm going to use this now to help me solve for c. So that's going to be log of my y, which is 0.80 over 0.47 to the base of 25 is equal to c. Working that out now in my calculator, I'm getting 0.16524 is equal to c. Question wants it to 3 decimal points, so c is going to be 0.165.